Hello everyone, here is a quick intro or recap about our project, experimental study on microservice orchestration with AWS step function. Our project is to build an e-commerce application in four different approaches, which are AWS step function express, AWS step function standard, event-based application, and code-based application. And we will test the performance and the cost between different approaches. Here is the experimental design for the event-based architecture. As you can see, event-based architecture is mainly connected by using Lambda functions and SNS in order to fully mimic the peak hour shopping orders. Let's say 1,000 orders at the same time. We first need to increase the concurrency capacity of each Lambda functions to 1,000. Multi-threading is also needed to ensure all orders are executed at the same time. Here is the experimental result about event-based architecture against three other approaches in terms of the runtime and cost. Now let's analyze the result from experiment. From 1 to 100, all four applications show a big jump and start to decrease from 200 to 400. After 400 and 500, event-based applications start to increase dramatically. Two-step function grows steadily. As we can see from 100 to 200, all four applications have a clearly dropped. This is mostly because of Lambda function processing is shifting from cold start to warm start. After 400 orders, the number of Lambda function execution will become the bottleneck of event-based and code-based approaches. In this case, step function has a better performance. Within a step function, express is better than the standard one. For the cost analysis of event-based approach, the cost is mainly from three parts: Lambda function execution, SNS, and DynamoDB. Since all four approaches has different charging policy, to compare with AWS step function, we estimated duration of order processing time to generate this graph. For the future work of event-based architecture, we could use another set of DynamoDB and SNS specifically to record the status of each stage. Once we finish one step, we broadcast the status for all steps, whether it is successful or failed. This would trace where the order stage is. We could also write another set of Lambda function to handle the error encountering during the process, but this can be complicated as Lambda function will likely spin in the loop, which costs unnecessary resources.
Hi guys, I'm Xiang Zhang, and my application is focused on Express workflow. So let's go over the architecture first. As you can see, our application includes three major components: order, charge, and shipment, including a series of states, including like the Lambda task states, DynamoDB task states, SNS notification task states. There are also choice states and wait states. And for the parameters I'm focused on is like the execution time, state transition time, number of states, stress test, and the cost. The first three parameters is majorly focused on comparison between Express and the standard workflow. And the rest two parameters is across all four applications. I need to manually collect the execution results log files since there is no already built backend API, especially for Express workflow. Let's go quickly for the workflows. Those four workflows are focused on a number of states experiments. There is one extra one for cross-application comparison. And the first parameter is a total execution time. As we can see, Express workflow is generally 37% faster than standard workflow. And the reason behind this is that like we use a JSON file to simulate the order as an event call, and the overall application is quite short-lived, and there are some idempotent action like the DynamoDB put operation, which is more aligned with the Express workflows, at least once model more closely. And overall, all those features, our application align with Express workflow more closely, which contributes to its performance. It's better performance than standard. And the next parameter is state transition duration. As we can see, the Express state transition duration is clearly faster than standard. And the reason behind this is that Express workflow doesn't store the state transition information, which greatly saves the time between the state transition. The next parameter is the number of states. I got 4 applications where I adjust the number of states by merging existing states into the Lambda states. We are also maintain the original function. This is the original 17 states application that I just showed you before. And this is 14th, where I remove the 3 choice states. The 9 states, I merge the DynamoDB test states into Lambda. For the 6 states, I merge the SNS text states into Lambda. The first observation is like between 17 states and the 14 states workflow. There are just subtle difference which can contribute by the number, the choice states. Since the Express workflow doesn't store the state transition information, therefore remove the choice states doesn't contribute much to the performance. Between the 9 states and 6 states, ideally, decreasing the number of states within one workflow will lead to the better performance. But actually, as we can see from this results graph, the 9 states and 6 states will cost even more time. And the reason, one potential explanation for this is like the Amazon step functions orchestrating performs better and more efficiently than invoking existing services within Lambda function. And another observation is that all the data points display the grouping behavior. This is because the Lambda states and the Lambda functions cold start, warm starts greatly affect the performance of existing workflow. The next part is like we give the workflows the payloads of numbers orders from 1 to 1000 to test its performance when faced with concurrent payloads. As we can see, the Express demonstrates the best performance, and I will leave the cost analysis to my team members. For the future steps, maybe we can add a backend API to directly export execution log instead of manually collecting. Another thing is that current application is aligned with the Express workflow more closely. Maybe we can add another application which fits the standard workflow more closely to test the performance and cost. Another thing that our current application is quite simple. Maybe we can add more steps or components to make it simulate the real world application. And that's all. Thank you.
Hello everyone, this is Shenjiu speaking. So now I'm to start talking about my standard workflow application. So basically, the application's architecture is the same as its SaaS workflow. We're using step functions to simulate an order service. So for my experience, in order to test the number of states, the influence of the number of states for the step function, I create 4 step functions four step functions with different number of states, but they all have they all can achieve the same feature. So basically, it's just to remove the choice state, DynamoDB, SNS, SNS lambdas, SNS, and for the part of function that removed, it will be added in the lambda. So that makes them consistent to implement the same feature. So for the experiment result, we can see like the total. We have collected data for the total execution duration and state transition. So since my teammates already discussed earlier, I will make this short. So obviously from the diagram, we can see that the expressive workflow is much faster than the standard function. And for my part, the result for the number of states and its performance is in this diagram. The first observation is the average runtime for 70 states is about 5 seconds, and while for the 40 states is doesn't have much that difference. So in our assumption, since the state transition time will reduce if we have less states, but this is not we see from our result. So so our analysis and from experiment, we find that the choice state, even if we remove choice state from 14 to 17, step 17 to 14, that choice state runs really fast, so it doesn't have much impact. And second observation is from 14 states to 9 states, the total runtime is increased. This also is also contradict with our assumption at the very beginning. But later we think that the possible explanation is a step function, and the orchestrator is more efficient when managing other AWS services. But if you trying to invoke all other services inside Lambda, this will take more time. The third observation is the group data pattern. They have pattern of keep increasing, but it doesn't have it doesn't show the same pattern as express flow. So we can see that the cold start or warm start of lambdas doesn't have a really significant impact on the standard workflow. So for our research and for our research and the future steps of the current limitation, first for step function, there is an internal API we can export detailed logging data. So in the future step, I think we could take advantage of that and to dive deep in more detailed data with the API's help. And another thing is our current application is relatively simple and only contains limited AWS resources. And there are also other very important AWS resources which could have some really obvious influence on the step function's performance. So in the next future step, I think we could include all this and trying to have more complex step function to simulate the simulate a real world service. All right, that's my part. Thank you.
Imdadul Al Imran. I was responsible for the API gateway or code-based implementation of our project, and I'm going to discuss the performance results of our project. But before that, I'll do a quick recap. So my API gateway architecture was a Golang based server that is responsible for orchestrating between the AWS lambdas. And we had 3 AWS lambdas. One is validate order, one is charge customer, and one is delivery package or shipment. And that's how it works. So the API gateway takes the request, call the appropriate lambdas, aggregate the results, and send the results back to the client. So I have also discussed about some advantages and some disadvantages of this API gateway architecture or code-based implementation. previously. So before diving into the results, I want to talk about the tool that I've used to measure the performance of our application. So I have used a tool called Ali. So Ali is a load testing tool that we can generate load. So it comes with detailed metrics and plots, as you can see in the animation down here. If I can zoom in, you can see this tool gives us all sorts of metrics related to performance that we're going to need, like total number of time it took to process the whole request, the number of requests that we have generated, the throughput, success rate, and the average latencies, minimum latencies, maximum latencies, all these sorts of metrics. So we have generated load for the following numbers, and we have measured the time it took for each implementation, and plotted it in a graph to see how each of the implementation performed. So this is the graph that you're seeing. So from the graphs, as you can see, the AWS step function express workflow is always the fast to process almost all the requests. So for thousands requests or 1,000 orders, it is the fastest one among the others. You can also see from the graph that AWS step function also scales pretty well and pretty fast compared to other implementations. So in my code-based implementation, that's in the red, as you can see, there's a huge spike. Also, the latencies or the number of time to process requests increases linearly with the number of requests. We can however improve the performance of our code-based implementation by using a bigger server. So the server that I've used for testing was it's an AWS Amazon EC2 instance. It was T4G small, that comes with 2 vCPUs and 2 gigabytes of RAM. So compared to other implementation, it's a pretty low-end CPU and low-end server. So this can be improved. This code-based implementation results can be improved by using multiple EC2 instances or bigger EC2 instance, or using ALB, application load balancer, or NLB, network load balancer. So there are lots of ways that this code-based or API gateway architecture can be improved to have a performance on par with the AWS step function. But as you can see, AWS step function has that scalability built in, so we don't have to do anything. That's the performance results analysis. Thank you.
For the overall product completion, we compared performance in 4 different approaches. We compared the cost in 4 different approaches. Within the step function express and the step function standard, we have more thorough comparison between their execution time and the state transition time. That's all about our project.